Hello everyone. Today we are going to talk about inequality of in one triangle. Okay, that's chapter 5.3. So let's get started. All right, the definition of inequality. It says A is greater than B if and only if there is a positive number C such that A equals B plus C. So what does that mean? So if A is greater than B, that means A equals B plus some number, okay? We don't know what that is, but in this case, we can say C, all right? And the converse of this definition also works, okay? So if 5 is 2 plus 3, then 5 is definitely greater than 2. 5 is greater than 3. Okay, of course. All right. So there are some properties right here in the table. Let me just read it through, okay? Comparison property. So A can be less than B, or A can equal to B, or A can be greater than B. All right. Transitive property, that's the second one. So if A is less than B, B is less than C, then A is less than C. Okay? The other way also works. A is greater than B, and B is greater than C, then A is greater than C. Okay? Addition property. If I have A is greater than B, I can add C. I can add C on both sides, and the inequality stays the same. Okay, it stays the same. Okay, subtraction also works. A is greater than B. Okay, if I subtract C, still the inequality, it doesn't change its direction, it stays the same. Okay, all right. Okay. Exterior angle inequality says, okay, if I have a triangle, not only I have three angles inside the triangle, but I also have, I'm going to change my color here, I can have exterior angle. Okay, that means that's outside of the triangle, right? So how many exterior angles do I have in a triangle? I can have right here, right there, here, there, and right here. So if I have a triangle, there are 6 exterior angles, okay? And the theorem says if my angle angle 1, that is an exterior angle of the triangle, correct, is always greater than angle B and A, okay? So exterior angle of the triangle is greater than the measure of either of its corresponding remote interior angles. In this case, we have the angle A and B. Okay, so let's solve the problem. Well, find the measures that is less than angle 1. Okay, so 1, what do we call this? That is my exterior angle of the triangle, right? So by the theorem 5.8, we can say that what are the remote interior angles of this triangle to angle 1? That will be angle PQR and angle QRP, correct? Okay, so angle 1 is the exterior angle. It's greater than remote interior angles, in this case these two. So I can say that the answer is angle 3, angle 4, angle 5, and angle 6. Okay. All right. How about 1B? 1b, it says the measure is greater than angle 8. Okay, so angle 8 is the interior angle. So which one is exterior remote? Okay, remote and exterior angle. That will be, in this case, I can see angle 2. So angle 2 is always greater than angle 8. Okay. Do we have any other? No. It looks like some of the angles, like angle 7 or angle 1, is greater than angle 8, but we cannot say that, okay, because we don't have the clue. By the theorem 5.8, this is the only answer we have, okay? You cannot say other angles are also greater than angle 8 because you don't have exact clue, okay? All right, let's move on. All right, here we have another theorem. It says angle-side relationships in a triangle. So if I have a triangle, let me redraw this because I need some triangle or something like that. Okay, so in this case, this is, let's say, 9 centimeters, and that is 7. So XYZ. XY is greater than what? YZ, correct? Okay, then angle Z, which is the opposite angle of the side XY. Angle Z is the opposite, okay? Is greater than, I'll change my color, angle X, which is the opposite of YZ, okay? So let me read the theorem right here. It says, if one side of the triangle is longer than another side, okay, just like now, then the angle opposite the longer side has greater measure than the angle opposite the shorter side. Okay, and its converse also works. So if the angle J is greater than angle K, then KL, the side length KL, is greater than JL. Okay, so let's prove that. All right. Okay, here is a paragraph proof, but I'm gonna rewrite this on the right side here. So let's say there is point D on the side AB. Okay, there is point B such that BD is congruent to what? BC. So that's our kind of like hypothesis. Okay. Number 2. So what do we know about the triangle DBC? Oh, it's an isosceles triangle. So we can say angle 1 is congruent to angle 2. Why? Because it is an isosceles triangle. So by isosceles triangle theorem. Okay. All right. Number 3. What do we know about it? I have angle BCA, that is angle 2 plus angle 3, correct? BCA is angle 2 and 3, okay? So what does that mean? Angle BCA is always greater than angle 2, and angle BCA is greater than what? Angle 1 as well, because it's isosceles triangle. Angle 1 and angle 2 are equal, okay? So this one is what we talked about in the beginning of this lesson by the definition of inequality. Okay, let me erase the space right here, and I'm gonna write number 4 up here. So, okay, number 4. So what do we know about this? Angle 1 is greater than angle A. Angle 1 is greater than angle A because we have what? Exterior angle theorem. Okay, by the exterior angle theorem. Angle 1 and angle A. Angle 1 is the exterior angle of the triangle ADC. It's the exterior angle, right? So we can say the angle 1 is greater than angle A. All right. The last one says angle BCA is greater than angle 1, as we talked about it, number 3. Okay. And angle 1, does it look like an angle? Angle 1 is greater than angle A. Okay, so that was from number 3. That was from number 4. So what can we say? Angle BCA is also greater than angle A. Okay, because BCA is greater than 1, 1 is greater than A, so BCA should be greater than angle A. So yes, now we proved it. Okay. Okay. All right, now let's solve some problems and we are done for this lesson. It says list on the angles and sides of the triangle in triangle ABC in order from smallest to largest. Okay, so I can see that the shortest side length is what? I want to change my color. Is AC, that's 3.7. That's smallest. Is smallest. And the next is 4.8, which is what? AB and BC. So the angle must be, which one should be the smallest? So let's look at AC. The opposite angle to AC is angle B, is smallest. What's next? The opposite to AB is what? My arrow should look something like this. Okay. C, and the largest angle has to be angle A. Okay. If I have a triangle something like this, then the angle measure right here in green should be 39 degrees. So I know that angle X is the smallest, and the next is angle W and angle Y, correct? Then I can say that the opposite side follows the same order. So the opposite to X is WY is the shortest, has to be shortest. And next is opposite to W, so that's XY. And what's the last one? Is WX. Okay, very good. The last problem of the lesson says, during lifeguard training, an instructor simulates a person in distress so that the trainees can practice their rescue skills. In the instructor training 1 and training 2, they are right here, are located in the positions shown on the diagram. Which one is closest to the instructor? Okay, so you guys can tell me the angle measures right here where training 1 is standing up. That is 60, 59, so what is it? 61, so that they can all add up to 180. So I can say that this one is longest, and the side on the left is the shortest. So what can we say about the answer? The answer is trainee 1, okay? Because it's opposite to the smaller angle, okay? It's opposite to the smaller angle. All right, very good.